Okay, so last time we met, we talked about the types of engineers there are, and we Googled and we found out there were really several different kinds of engineers. Some engineers you probably never heard of. And so I had asked you to jot down some one-liners about the following engineers. See, the first one, let's talk about industrial engineering. Industrial engineer. Okay. Lauren, what did you find out? Well, what's an industrial engineer? What do they do? Unmute yourself, Lauren.
For industrial, I put devise systems for workers, machines, materials, information, and then to make a product or a service.
Okay, all right, that's good. Does that jive about what everybody else got? Everybody else kind of agree with that? Okay, so industrial engineering is an engineering that they do like process engineering. They are very interested in the process, how the process works, how to optimize processes. Things they do, they design cockpits in airplanes, how to engineer the cockpit so it's human friendly, it's easy access, and those type of things. So it's actually quite interesting stuff, right? That's what industrial engineers do, okay? All right. System engineer. Ezekiel, what do system engineers do?
I do not know. I was not here yesterday.
I can't hear you, Ezekiel. You have to speak up.
I do not know. I was not here yesterday.
Oh, you were not here yesterday. Okay, never mind. Henry.
A system engineer oversees an entire system in a variety of fields. Their job is also to develop a system that is efficient and creates a product from beginning to end.
Okay, good. That's really nice, really great, succinct definition there. Okay, so system engineer is kind of a branch off of industrial engineering. They are really interested in optimizing a process, a system, or whatever you might have, okay? So can anybody tell me what kind of things that a good system has? I've talked about this many times in my classroom, so you guys might know. One of the things that a good system has is what? Has a feedback loop, right? You have to have a feedback loop to continually get better, okay? We always talked about that in my classroom. Okay, so that's kind of what system engineers do, all right? Okay. Civil engineering. Logan, what does a civil engineer do?
Civil engineers create and design public structures and roadways in a safe and purpose-built way.
Okay, all right. So civil engineers build stuff, right? They build stuff. They build bridges, they build what? Dams, you know, these type of things. Nice, big, very, like you said, with purpose, they build very big structures. That's what civil engineers do, okay? Very interesting. One of the benefits of being a civil engineer is that you can, after you grow old, you can go there, take your grandchildren and say, hey, that bridge over there, see that one? That's me. You can say that if you're a civil engineer, right? Okay. All right. Food engineer. Food engineer. Aka, what does a food engineer do?
Food engineering combines engineering principles with other fields such as microbiology,
Microbiology.
and using engineer principle to the storage, processing, and distribution of food.
Good, good. So what do food engineers, so what kind of things are food engineers interested in? What are they worried about? What things do they develop? They would do things like GMO, right? One of these things, GMOs. They're also worried about getting the proper RDA. What does RDA stand for? Sam?
No, I don't know.
Recommended daily allowance, right? You look at a food label, it has the RDA, right? That kind of stuff, right? How much saturated fat you can have a day, how much salt you can have a day, right? That kind of stuff, right? What else do they develop? They develop what? They develop best eat by days, right? Best eat by days. You guys ever go to somebody's house, ask for the ketchup, look at the ketchup aisle, and it's like 2 years past its expiration date? Everybody had that happen? I know that happens quite often in my family. What does it mean when you go past the eat best by day? What happens? What does that mean? Anybody?
It won't taste as good.
Okay, it could possibly not taste as good, right? It doesn't mean that if the sell by or the best by date is today, if you eat it today, it's okay, and if you eat it tomorrow, you're gonna get sick and you're gonna go bad. It's gonna go bad and you're gonna go sick, right? It doesn't happen just like that, right? I mean, if you're a food engineer, right, and you have some sort of food product here, okay, and I say that the eat best by date is, okay, if this is the eat best by date, and the date is, 7 days since you purchase it, okay, that doesn't mean it's gonna go bad the 8th day. Because as an engineer, if you do the calculations and you say that, okay, I actually have from here 14 days, okay, then you're gonna say the eat best by day is 7 days. And why am I doing that? What is this thing here called? Does anybody know what this thing here is called, this period here? So the food engineer has engineered or taken into account a 50% safety margin, right? In other words, okay, I know for sure it's probably gonna go bad around the 14th day, but I'm gonna say label it as 7 days so that I give myself some breathing room here for the safety of the consumer. Does that make sense? We good with that? So that's what the safety margin is. So any design, a civil engineer, an elevator, when you're designing an elevator or something like that, if you design an elevator and you do all the engineering calculations and you find out that it will take, 6,000 kilograms, okay, you're not gonna put the maximum weight at 6,000 kilograms, right? You're gonna put the maximum weight at something greater or something less than the 6,000 kilogram? Ezekiel, what would you do? Would you put
I
it at
would,
3,000 or 9,000?
3,000.
You gotta put it at 3,000, right? You put it at 3,000 and you give yourself that extra 3,000 or extra, in this case, it would be 50%, right? Extra 50% safety margin. You would give yourself a margin so that something's not gonna happen. So not only that, it gives you it takes you away from the liability, okay? Another good thing for going back to the food engineer is what? People throw things out earlier, they have to purchase more stuff, huh? So that's good too. All right, so, okay, so we're going off on a tangent there. So that's what a safety margin is, okay? But these are the things, the eat by or sell by dates, food engineers would do, okay? What are some of the things when your parents go shopping for groceries? What do they look for? What do they do not want to have in their food? What's bad for you?
Sugar.
Sugar. Okay, say they want to design stuff with less sugar. What else?
GMOs.
Okay, they want non-GMOs. What else?
Carbs.
Carbs. Okay, all right.
Fat.
Fat. What kind of fat?
Good
Saturated.
question.
Saturated fat, right? Or trans fat, although most of the stuff does not have trans fat anymore, okay? What else?
Salt.
Huh?
Salt.
Salt. Aka. What is a big thing that people don't like in Japan?
Um,
MSG, right?
yeah.
Right? They don't want MSG. Does anybody know what MSG is besides Aka? Monosodium glutamate. Okay, this is the stuff that makes your food taste good. Okay, it is the umami in like stuff like ramen. There are lots of MSG in that. So it does make the food taste good, but it's not really good for you. Okay. By the way, I like stuff that has MSG. Okay, so that's food engineer. Last one was microelectronics. Oh, we listed all these things, right? So food engineers are going to try to develop food that have less amount of those things, correct? So that's one of the things that the food engineers do, okay? All right, last thing but not least, we have the microelectronics engineer. Microelectronics engineer, Sam, what does a microelectronics engineer do?
They design small electronic parts like semiconductors, circuit boards, and microchips, and then they use them in designs of new like biomedical, electronic, aerospace, and information technology devices and systems.
Okay, so name me where one of these people might work at, a company.
NASA.
NASA, okay, good. Would they work for like Intel, right? CPU design, correct? That kind of stuff, that's what these would do, they would do, right? Okay. Okay, so those are the 5 things. Okay. I am going to, okay, so these are the things, these are the type of engineers there are. Okay. I'm gonna give you 5 minutes from now till that time is 9:20. I'll give it till 9:25. I want you to research and find out what are the 4 basic engineering disciplines. In other words, out of all these different engineerings that we talked about, the 30 kinds that you researched, actually there are many, many, many more, okay? All these engineerings, there are 4 engineering disciplines that are considered the basic engineering disciplines. You have 5 minutes, find it out. All right, does anyone need more time? Let me know if you need more time. All right, Logan, tell me the first one you found. Just one, Logan.
Civil.
Civil engineering. Ding, 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 ding. Winner, winner. Ezekiel.
Chemical?
Chemical. All right, another winner. Lauren.
Mechanical.
Mechanical. Great. And the last one is
Electrical.
electrical. Okay. So these are the 4 basic engineering disciplines. Okay. What that means is the rest are really what we call applied engineering. Okay. So they are some form of these 4 things combined together. Okay. So as some of you know, I used to be a nuclear engineer. As a nuclear engineer, okay, you needed to know this, this, and this. Okay. So it's a combination of those disciplines. Okay. So my bachelor's was in electrical, but my master's was in nuclear. So I had to know kind of like all these things, all right? Okay. So that's the type of thing. So aerospace engineering, same thing, okay? You have to know this, and probably again a little bit of this, okay? So these are the things. So other ones are called the applied engineering. This is called the 4 basic engineering disciplines, okay? All right, so that's that. And let's see. Okay, 2, 3. Anybody tell me what the hardest thing is here out of the 4? Anybody know? Anybody want to guess?
Mechanical?
Electrical.
Electrical is actually the most closest to math. So if you're good at math, if you're fairly comfortable with math, electrical comes pretty easy, okay? To me, mechanical is the toughest because mechanical requires you to know many different things. You have to know thermodynamics, you have to know fluids, you have to know structural. There are just many, many, many things you have to know, okay? Whereas chemical and civil are kind of not so much. So the reason why you can find that these are also the basic engineering is because if you studied one of these 4, you can apply to different jobs. In other words, it's easier for you as a mechanical engineer to apply for or an aerospace engineering position or, something else. The other way around is not as easy. So if I graduated as a nuclear engineer, it's not that easy for me to try to apply for a mechanical engineering position. Although there are times that it will work, okay? It is less easier to do that if you were going the other way around. If I was a mechanical engineering person and tried to apply for a nuclear engineering position, there are many positions within the nuclear engineering field that you can do with only a mechanical engineering degree. So same thing with chemical engineering. Okay, chemical engineering, it sounds like you're in the lab doing this and that, and you don't do much. But if you look at some of the things that they do, some of the fields that they work in, it's petroleum, it's they design polymers, they do plastics, they do Winchester, right? Winchester guns, those type of people, they hire chemical engineering. Now I have a niece who's a chemical engineer who works for Samsung. Okay, she works in the manufacturing of the actual crystals that make, that they do stuff, make DRAM and SRAM and memory chips and all that stuff. So there's many, many applications, okay? And that is why, another reason why they are called the basic engineering disciplines, okay? Okay, so we're gonna call it good for the first part.